Hey guys, systems of equations in two variables, and we're solving using the substitution method. And what the substitution method simply means is plugging one equation into another. Let's look at an example. Use substitution to solve the system. I'm given two equations, equation 1 and equation 2. I have written equation 1 in red and equation 2 in blue. Since equation 2 already has a variable isolated, in this case y, this is going to be the equation that I use to do the plugging in. I'm going to take equation 2 and plug it into equation 1. It already says that y equals x minus 8, so I'm going to take x minus 8 from equation 2 and I'm going to plug it into equation 1. Again, it says y equals x minus 8, so I'm just going to take x minus 8 and place it in lieu of y. I kept equation 1 written in red, and the portion of equation 2 I've kept in blue. So again, I took x minus 8 and plugged it in place of y. So I end up with x plus x minus 8 equals a negative 2. Combine like terms, solve. End up with the value x equals 3. Then I take x equals 3 and I plug it into either equation 1 or equation 2, and I solve for the value of y. For equation 1, I ended up with y equals a negative 5. Equation 2, I ended up with y equals a negative 5. I should end up with the same value for both of them. My coordinate is 3, negative 5. This is the same example that we had from graphing. It does not matter which variable I solve for first. I can solve for either x or y. Use the one that makes it easier to do the work. And it doesn't matter if it's equation 1 or equation 2. I could take this system of equations and I could just flip them around and then say, well, this is equation 1 and this is equation 2. It doesn't matter. This is just a means to be able to label, and especially to help be able to explain with my written instructions. So let's look at some examples. I think it's rather straightforward what you're to do. Isolate a variable and plug it into the other equation. So if you would like, pause the video, solve, see if we can find a solution to these equations, and see if we can have the same answer. Alright, so the first thing that I look at is I look and I see, are these equations that I'm given, equation 1 and equation 2, are they dependent? Are they the same form of the equation? I can get one and obtain the other. No. And then I look at the slopes, and I can't really see the slopes in this form, so I can't really discern any of that. So when using substitution, I'm not going to rewrite in y equals mx plus b form, slope-intercept form. What I'm simply going to do is I'm going to pick equation 1 or equation 2. Which one is easier to just isolate a variable by itself? Well, equation 1 is. I can simply move one of the variables over and then have a variable isolated. With equation 2, I do that, and then I have to divide by something. I end up with fractions, and I would rather not do that. So what I will do is I will take, let's say, equation 1, and I'm going to rewrite it, and I'm going to solve for, we'll say y. How about that? Y equals 9 minus x. In equation 2, I can just leave the same. Equation 1 is still the same equation. I've just moved the variable around. Now I'm going to take my value of y from equation 1, which is 9 minus x, and I'm going to plug it into equation 2. And I'm going to combine like terms and solve. Now I take my value of x and I plug it into either equation. I'm going to plug it into equation 1 because the math is just, it's simpler. So I'm going to say 5 plus y equals 9. Y equals 4. And then the one thing that I should always do is verify. So for equation 1, I'm going to plug in my x and y values. 5 plus 4 equals 9. That is a true statement. For equation 2, 2 times 5 minus 3, whoops, I'll do parentheses. 3 times 4 equals a negative 2. That's 10 minus 12. A negative 2 equals a negative 2. This is my solution. Alright, example number 2. If you need to, pause the video. If you messed that one up and you need to rework 2, go ahead and pause it. Alright, so for equation 2, or example 2, sorry, I know what x equals in equation 2. So what I'm going to do is I'm going to take that value of x and I'm going to plug it in for x. And I'm going to solve for y. So I know that x equals y plus 4, so I'm going to take it and plug it in there. So I have y plus 4 minus 2y equals 7. Combine like terms and solve. I have a negative y equals 3. Therefore y equals a negative 3. So now I take my value of y and I plug it into one of those two equations. And you do the one that's easiest for you to do the math. So I'm just going to say, because what am I solving for, x, I'm going to use equation 2. X equals a negative 3 plus 4. X equals 1. So what I'm saying is I have this, 1, negative 3. And I can verify. I can do equation 1. And you need to do both. Don't just do one in order to verify and say, yes, this is the solution. I can have 1 minus 2 times a negative 3 equals 7. Well, that turns into 1 plus 6 equals 7. 7 equals 7. That is true. We're going to do, and I need to do equation 2. And I say 1 equals a negative 3 plus 4. 1 equals 1, and that is true. Oops. And that is how to solve using substitution. Sorry, this is my solution. So, watch the publisher's videos, critically think and structure your homework, and good luck on doing the substitution problems.